I'm Sangeetha, Assistant Professor, Department of Costume Design and Fashion. This is a lecture video. Today we are going to see about knitting technology. Loops from loops to fabrics, exploring the science, history, and innovation behind one of the world's most essential textile process. The genius of knitted fabric. At its core, knitting transforms a continuous strand of yarns into a flexible, cohesive fabric, all through the elegant geometry of interlocking loops. It has two main major categories. One is the needle loop, the fundamental unit of knitted fabric. A new loop is drawn through an existing one, building the structure row by row. Knitting versus weaving. Unlike weaving interlaced warp and 50 yarns, knitting relies on loop formation, creating a more elastic, conforming fabric. A historical leap from handcraft to machines. Early origins hand knitted techniques date back centuries, practiced across cultures for warmth and trade. And second one, 1589, the breakthrough Reverend William Lee invented the first knitting machine using a beard needle mechanism loop formation for the first time. Then third one, the latch needle. At later innovation that simplified the mechanism, enabling reliable high-speed mass production. Modern era. And nowadays, the computerized machines now produce the complex fabric with precision, speed, and minimal wastage. Next one is two pillars of knitting. It has the two main pillars of knitting. Then one is weft knitting and another one is warp knitting. Weft knitting. This diagram shows how the yarn is interlooping of warp and weft knitted fabrics. Then first one we are going to see about weft knitted fabric. Loops are formed horizontally across the fabric with typically from a single yarn. Highly versatile and used for a wide range of products including sweater, hosiery and activewear. Warp knitting. Loops are formed vertically along the fabric length with each needle fed by its own yarn. This is the fastest method of yarn to fabric conversions. Ideal for technical and fine fabrics. Next is key components of knitted fabric. It has three main key components. One is needle and second one is singer, third one is cam. This is the three elements are used in knitting machines. Needle has three types. Okay, first we are going to see about a needle, the heart of every machine, available as beard, latch or component types. Each forms a loop with distinct machines and speed capabilities. Then second one is singer, thin metal plate that assist in loop formation, hold down the fabric and control the yarn tension between needle. Okay. Then third one is cam, guiding the tracks that direct needle movement with precision, controlling the rise and fall of each needle in the knitting cycle. Understanding the knitted loop structure. Knitted loop structure has these are the terms of knitting. Then first one is veils, vertical column of loop running along the fabric length, the longitudinal backbone of the structure fabric. The next second one is course, horizontal rows of loops across the fabric width, building the fabric row by row. Stitch density, loops per unit area, directly influences fabric thickness, weight and textures. Then fourth one is stitch length, yarn consumed per loop, the dominant factor controlling the fabric properties like drape, stretch and porosity. The unique properties of knitted fabric, stretchability and elasticity. The loop structures provides a high degree of stretch, offering comfort under conforming fit, ideal for activewear and intimate apparels. Soft handle and drape. Knitted fabrics possess a softer feel and excellent draping qualities compared to woven equivalents. Bulkiness and insulations. The open loop structure drapes air, providing natural warmth and thermal insulations. Absorbency and crease resistance. Generally more absorbent and resistant to wrinkling. Practical for everyday garments and sportswears. Evaluation of knitted machines. A knitted machine has major three categories: flat knitting machines, and second one is circular knitting machines. Third one is specialized machines. Okay, first we are going to see about flat knitting machines. Flat knitting machines produce a fabric in a flat sheet, ideal for integrate designs, shaping and fully fashionated garments. Circular knitting machines create a seamless tubular fabric at high speed, the backbone of t-shirt, underwear and the socks production. Specialized machines includes Rachel, Tricot, hosiery and full fashionated machines, each engineered for specific fabric types and applications. Advanced knitting technology. Full fashionated knitting. Garments are shaped precisely during the knitting, reducing cutting waste and improving fit. A key drives of sustainable manufacturing. 3D complete garment production. Entire garment are knitted in one piece of with no seams, revolutionizing apparel manufacturing and enabling on demand productions. Checkered and patterning devices. Computerized systems enables complex color work, structural patterns and textures to be integrated directly into the fabric during knitting. Knitting technology, a foundation of modern textiles. From reveredly 1589 frame to today's 3D whole garment machines. Knitting has evolved into one of the most sophisticated industrial process in the world. Innovations. Fundamental principles driven breakthrough in textile designs and engineering. Sustainability. Full fascinated and seamless knitting reduce waste and energy in apparel production. The next one is performance. Advanced technologies enable the fabrics with superior comfort, fit, and functionality. Thank you.